Hey guys, welcome to Longmos. So I'm guessing you're here to look out for the demo class. So the demo class is basically our first class of the entire batch. So we don't have this thing as demo class as such where we'll just show you all fancy things and tell you this is what you'll be capable of doing. No, that's not what it is about. So it's going to be a part of the syllabus and it's actually the first class. So if you guys are being a little skeptical as to how the entire environment is going to be like, or if it's going to suit your taste and if it's going to suit your overall liking, then you can just have a look at this particular video. It's one of the first class of a batch that it was for a set of architects, so you guys can know the entire format. Since it's the first class, I always expect all of you to turn on the camera, have a bright light on your face so we can all see each other interact, because we don't want it to be a one-sided session. So it should be a more of an interactive thing where we get to know each other who is there, because architecture is a small niche community and we really want to grow it together. So what better way than connecting online in these times, right? So not just that, now if you want to see as to how the class format will be, you can skip the first 20 to 25 parts or 25 minutes of the video, because that's going to be like the introduction part. Since it's the first class, I would have taken for a batch, and then you can see actually how we dive into the topic. Hi Diksha, welcome to the class. Am I audible? Hi Shashwat, am I audible? Awesome. Diksha, am I audible? Okay, so I hope all of you can hear me now. So Rishwant will be your tutor. He'll be taking Rhino and Grasshopper for you guys. So he'll just be connecting now. Okay, so until he comes, like I just want you guys to quickly introduce yourself. Like you can just tell your name, and then if you're working or studying, so we just know who's around us. So just to start off with, I'm Chaithanya. I'm a part of Lomos, and I handle Revit and B.I.M. So I just want to know who all are connected over here. So probably I can start off with Tanvi.
Hi, I'm Tanvi and I'm a student in Manipal. Can you hear me?
Yeah, you're audible, Tanvi.
Yeah, I'm a student in Manipal. I study third year architecture.
Okay,
Yeah.
that's nice, Tanvi. It's nice to have you here. Sanya, you can introduce yourself.
Hi, I'm Sania Mukhtar. I'm in my 8th semester architecture in Ramaya Institute of Technology.
Okay, nice to have you here, Sanya. Shashwat, you can introduce yourself.
Hi, I'm a junior architect and I passed out from Manipal University.
Oh, that's nice. Diksha, you can introduce yourself.
Hi, I'm Diksha. I just passed out from B.M.S College and I'm currently unemployed.
Okay, nice to have you here, Diksha. Pragya, you can introduce yourself.
Hi everyone, I'm Pragya. I'm working as an architect at a firm in Delhi since the past 2 years.
Okay, that's nice, Pragya. Anjali, you can introduce yourself. Samir, are we audible meanwhile? Are we audible? I think Anjali's audio is muted. So anyway, the person who's going to be teaching you, right? So his name is Rishwant. So he passed out, I think, in 2014, if I'm not wrong. So he's a senior architect. He's working in a company called Jurong. That's an MNC in Bangalore. So now he's a part of Lomo. So we have an architectural firm as well. So he's a senior architect. Plus, meanwhile he takes Rhino and Grasshopper classes. So he'll just be joining us now. Okay. So have you guys worked with this thing before? Have any of you worked with Rhino before?
No.
Okay, but I hope all of you installed Rhino. Okay.
Yeah.
Yeah.
Okay, that's great. Let's see.
So one doubt that I have.
Yeah.
So in this class, would you be teaching like Rhino from scratch or Grasshopper?
Both of
Like,
them.
So, okay. So how
Yeah.
long will Rhino take? Because
So Rhino is usually, when we take classes like offline, it goes for about 12 to 14 hours. Okay. So over here, we have planned it for about the same time. So, if you're considering about 1.5 hour each day, then, we're hoping we can cover it in 7 days. So, it basically depends on the speed of the class, because it's not going to be a one-sided session. We'll want you guys to work with us. So if you guys are taking a little longer time, then it's going to probably extend by another 2 classes. Otherwise, it's going to go well within our schedule.
so will Grasshopper be taught simultaneously with Rhino?
Oh, no.
Or
So Grasshopper is a plugin for your
that's why
Rhino.
I'm
Yeah.
asking.
So it'll be done only after Rhino, because without you guys knowing Rhino completely, like, you can't go to Grasshopper, because it's completely based on Rhino itself. So you
Yeah,
need to be
so
perfect with Rhino, and then,
okay.
you're going to start with Grasshopper.
So the class is of 10 days, this class, right?
So see, with the 10 days is on schedule, but in case you guys tend to take a little longer, then it might go to 12 to 13 days. And then at the end of your entire course, before we give any kind of certificate or something, we'll want you guys to work on a project of your own. Okay, but then it should be compromising of all the things that you have learned in the class. So and that class might take another extra 2 or 3 classes, because we'll want you to model it with the tutor, so we know that you have the perfect understanding of the software and you've used it on your own software as well. I mean, on your own project as well. So that's how we know that you know it perfectly. And then when you're doing a project, you'll actually come across a lot of doubts that might have not been covered in the class as well.
Okay, thank you.
Okay. Yeah. Samira, are we audible? And I think we have Harsh also in the class. Harsh, am I audible? So Rushwant is here.
Yeah, hi. Hi guys. Sorry, I ran into some trouble with the laptop. They've joined in, and yeah, to start with, I'd like to get an idea from all of you as to whether you're students, practicing professionals, or teaching professionals maybe. So yeah, let's just start with like a round of intro. Shall we start with Diksha?
Hi guys, I am Diksha, and I just passed out from B.M.S College of Architecture, Engineering, sorry, and I'm currently unemployed.
Right. Fine, Diksha. Hope this course helps you in the way you're looking for it. All right. Going forward with Tanvi.
I'm hi again. I'm a student in Manipal, third year.
Pragya. Hello, Pragya. Are we audible? Hello. All right. Let's go ahead with Samir. Samir, are we audible? Hello. Guys, it's better if you guys can participate, all right? Because it helps us to, understand different methodologies also later in the class. Because to make any one kind of a let's say model or geometry, there are a number of different ways how people would think. So it's better if we kind of like take this class as a more like a not like an online, but more like a physical, like actual presence class itself, where we are all interacting together. Okay, fine. Shashwat, can you go ahead?
Hi, I'm an architect who's working in currently working in Delhi and passed out from Manipal.
All right, cool. How long have you been working for, Shashwat?
I passed out recently this year only.
Fresher then.
So yeah, fresh architect. Yeah.
And Sanya?
Hi, I'm an 8th semester student from Ramaya Institute of Technology.
Fine. Let's move on to Anjali and then Harsh. All right. Anjali says there's some issue with her mic. That's all right. And she is a recent pass out from UVC and is working currently in Bangalore. Nice. Okay, cool. Harsh? Harsh? Are we audible? Are you able to hear what we're talking? Are you there? Not there, or there and not, and you don't? Yeah, all right. I can hear you. No, I can't hear you. Sorry, I can only see you on your text.
That's okay, Rushwant. I think you can just start off with the
I
class.
think
We'll be
we'll
able
just
to
start it
follow.
off.
Yeah.
All right. Let's see. First, I'll just start off with a brief introduction of what Rhinoceros and Grasshopper as a software is, right? So, to like talk about the history of these tools, these things basically began as as a plugin for architecture itself. I'm going to start with sharing my screen now. Right. Are you all seeing my screen?
Yeah.
Okay. Yeah. So as I was saying, it started as a plugin for AutoCAD, and only in the late 1990s was when this became a standalone software, right? And this was primarily used by naval architects, people who go ahead and build like naval vessels or boats and sails. So those were the designers who were using it, but seeing the flexibility and the versatility of it, a lot of different types of designers started to apply this tool in their professions as well. Like, for example, a lot of you are architects and designers, so you know how these tools are used. And apart from that, it's used for milling, it's used for, aerospace engineering, it's used for furniture designing, jewelry designs, product designs. So the kind of range that this software caters to is huge. And these are some of the major world players or companies that are making use of this software. And as I was saying, yeah, you do have Boeing as well. So yeah, you can even see some architecture firms and other automobile industries, there are construction industries that are using this software. Going forward, there are different verticals also in which the software can be used. So one vertical is your architecture, interior design, and graphic design part. So you can even export your models or geometry in terms of graphic designs, or even in 2D or 3D formats. Now, apart from that, you even have engineering applications for it, like you can get, milling designs. You can get prototyping files, like you can get 3D printable files out of this. And also, of course, you can even model characters and use it for rendering as well. So yeah, the kind of application that this tool provides you with is actually very stagnant. Moving forward, I would like to make a few suggestions also to you. and that is to try and understand the perspectives and projections while you're drafting or modeling any sort of geometry. It's always a good idea to start with a sketch. This is something I try to stress on, at multiple stages in our course as well. But yeah, a sketch, even though it may sound that, okay, we are starting a computational design course, and I'm asking you to start things with a sketch. It may sound bizarre or weird, but yes, that is this is always a very good place to start, so that you understand as to what the model is, and then you can visualize, or you can understand the modeling sequence as well, like how we are going to proceed with it. Of course, the tools and gizmos, we're going to be discussing it now. All right, I hope that gives you a brief idea of what the software is and how you can use it, and how it is being used as well. Now, going to the software itself, this is how the interface looks. And I hope all of you have the software installed. Any of you who doesn't have the software installed? All right, I'm going to take that as a yes. You have, all of you have the software installed. Now, see, as you can see, the first thing that you notice as soon as you open the software is you have these four windows, the four viewports that you can notice. Right off the bat, it's different from your SketchUp, because over there you will have just one window where you're working on, and that window is going to give you a perspective projection, or a 2-point perspective, or a parallel projection, or whatever it is that you are selecting. Whereas over here in the same 3D environment, you're going to get multiple projections in multiple windows or multiple viewports. So that makes for a much more interactive, much more easier kind of a scenario for modeling also. What we have out of these four is three of them are orthogonal viewports. So you can see that over here: top viewport, the front viewport, and the right viewport. And one of it is going to be your perspective viewport. So this is your viewport section, and this is where we'll be modeling everything. Up top over here, you have your menu bar, and over here you can see all your file drop-down menus. So you have places where you can open a new file, open a file which you have saved earlier. You can save the current existing file, import, export, all of these things you can do it over here. You can do all your editing functions on the next menu bar over here. You have things like grouping, ungrouping, blocks, shading blocks. You can set the visibility. You can create like joins, explode things, and all of those kind of tools. Then you have viewing options. We have different viewing modes like wireframe and shaded. We'll get to all of these things. I'm just trying to give you a brief idea of what these menu bars hold. Then you have a whole section for curve tools and curve creations. And similarly, you have for surface station and surface tools. And similarly for solids. So you have neat sections for curves, surfaces, and solids. And of course, another section for the meshes. Finally, you have drafting tools like adding dimensions, giving text, creating hatches, and that sort of a thing. Also, you have a whole section for transformation tools like moving, copying, rotate, scale, align, orient, array, blah, blah, blah. Finally, you have certain other tools also, which includes Python scripting, Rhino scripting. We'll be looking at these things very briefly. And also you have analysis options. We'll get to this as well later in the course duration. Rendering is something that we'll not be covering in this course, but however, Rhino, as I was mentioning, it caters to a lot of different tools and a lot of different verticals. There are people who use it for modeling and rendering solely also. So yeah, this has a rendering tool also which you can plug in. And yeah, panels is something that we'll be looking at later. So yeah, that's your menu bar. Now after that, you have your command line, and probably your command line looks something like this, right? I would suggest you to keep a few lines of the command line visible. The reason is many of the tools that are there in Rhinoceros, they have multiple options while you're executing the command as well. So all of these things will be shown over here in the command line, and also while executing any command, it'll even tell you as to what is the next sequence for it, like what you need to do to properly execute the command. So you can just blindly follow whatever is being told on this command line. So as a result of that, I would suggest you to keep a few of these lines visible over here, right? Next to that, I have something called a selection filter. Probably you don't see that, and that is something that comes after customization of your interface. So we'll be getting into that, and once we get a hang of the software, then you can later on decide whether or not you want to have this kind of a menu bar over here. After that, you have over here your standard toolbar. So this toolbar allows you to bring in or take out multiple types of tabs. Like you have the standard tab, which allows you to open, close files, pan around, zoom around, and so on and so forth. You have construction planes tab, set views. You have ways to set different types of display, selection tabs, viewports, visibility tabs. As I was saying, transformation tools, like all of the things that you saw over here are also available over here. Then comes the curve drawing tools. You have the curve drawing tools over here, then the curve modification tools, I would say. So those are over here. And these are the same tools that you saw over here in the menu bar as well. So the same way how you can create a circle, you have those things over here as well. So you can create a circle over here as well, or from here. Same way you have surface creation and surface tools. So surface modification tools are over here. Surface creation tools are over here. And similarly solid creation and solid tools. Now I have made a few changes to the standard bar, and you can standard toolbar, and you can do the same also. If you want, you can do so by clicking on this options, the small gear icon that you see, and you can go down to show toolbar, and you can bring in any of these toolbars that you want. So of course, yeah, we'll be looking at all of these things later on. I just wanted to give a brief idea about the interface itself. Right, so yeah, these are the kind of tabs that you would see. I have made a clean section of curve drawing and curve tools. Then I have a section of surfaces, so surface creation and surface tools, and solid creation and solid tools. So that for me makes sense, and it's up to you as to how you want to use your interface and customize it as per your requirement. Finally, you have the mesh tools and render tools, or something that we're not going to be discussing. All right. Then we have, yeah, of course, your four viewports, as I was saying. And after that, it's showing the four different viewports that we have. And it's also going to highlight the viewport that we are working on. So right now it is showing this top viewport highlighted, and the same is highlighted over here in this section as well. The moment you switch to front, it's going to show the front, and same way to the right, it's going to switch to the right. Now, of course, after that, you see a small plus icon over here, and that allows you to create a new floating viewport. So for those of you who have, like say, for example, multiple screens, you can always create a floating viewport and dock it into the other screen and use it as a perspective. It gives a very good feedback. It's always nice to have multiple screens anyway. So yeah, that is it. Then after that, you have the snapping menu. So this is the snapping menu that you have. And down underneath that, you have your unit settings, and the current layer of any object that you will select is going to be shown over here. And down under over here, you will have your gizmos basically. So these are all gizmos and tools that will help you to model in a more efficient manner. So yeah, you have grid snapping, you have ortho. Grid snapping is nothing but you can turn it on or off, and it will like your cursor will either snap to the grid intersection, or it will not snap to, based on the grid snapping, whether it is on or off. Ortho works in the same fashion as AutoCAD. Planar is something that we're gonna understand with the help of modeling. Then you have OSnap, that is object snap. It will help you to turn on or off multiple types of snapping options that you have over here in the menu. And you have smart tracking, which we'll get to later on. And Gumball is a new feature in Rhinoceros. It has come into picture after Rhinoceros 4 point change or something, or 5, I think. We are seeing Gumball, and it's a very effective tool, and we'll be discussing that also in detail. Yeah, now to navigate around in these viewports. First thing I want to point out is that if you double click on any of these viewports, it's gonna snap to full screen or snap back to the previous kind of the viewport setting that you would have. You can always go back to the initial setting with the help of viewport layout and set it back to your initial core viewport default viewport settings. And you can zoom in or out with the help of your scroll wheel on the mouse. So you can zoom in or zoom out. You can also do it with the help of your right mouse click button and control. If you click the control key on your keyboard and use the right mouse click button together, it's going to zoom in or out again. Right. Same way you can pan around in the orthogonal viewports. You can pan around with the help of right mouse click button. I want you all to just try these things out as we are speaking. And if at any point of time you have any doubts, you can immediately ask. And if someone feels that we are going fast or slow, please go ahead and give us back feedback on that so that we can adjust the pace of the class accordingly. Okay, so yeah, we can pan around with the help of right mouse click button. In the perspective, however, it works differently. With the right mouse click in the perspective allows you to orbit. Okay, and if you want to pan in the perspective, you are going to have to press the shift button along with the right mouse click button. Okay. All right. Any doubts, guys, up until now? All right. Now we're going to start with the basics of the different types of geometries that are there in Rhinoceros. So to start with, we want to categorize the types of geometries that we have. So the first category is points. So you have points like these. Then you have curves. So curves can be either straight or it can be curvilinear also. We'll get to executing these commands individually later on. First, I just want to mention the different types of geometries that we have. So you have points, you have curves, and then you have surfaces. Right, you have surfaces like these. And finally, you will have polysurfaces or solids. Right. So these are the different types of geometries that we are going to be dealing with. So first type is points. Then you have curves, and curves you can have it linear or curvilinear. And of course, another type is closed curves also. So this is a closed curve, that is a rectangle. You can have similarly like circles as well. And yeah, so these are all your types of curves, right? Then you have surfaces, right? So these are surfaces, and yeah, surfaces can again be linear. Like this one is a planar surface. You can have it non-coplanar and curvilinear surfaces as well, right? Or organic surfaces is what we can call them. Then finally over here you have solid, or you can call them a polysurface as well. I'm gonna just make a copy of this. And, I'm gonna explore it. We're gonna get to using all of these commands again, but I just want to tell you as to what constitutes for a polysurface and what constitutes for a solid, right? Now this one has one of the faces taken out of it, so this becomes a polysurface, whereas this becomes more like an extrusion of a rectangular closed curve, and it is more like a solid, right? Both of these are polysurfaces, whereas this is more like an extrusion, which is a solid. Now finally you have a special case also. The special case is a sphere or an ellipsoid or even a torus and such geometries as well. Uh, so this is a special case. The reason why I say it is a special case is because when you select this, it shows that it is a single surface that has been added to a selection, which is the same as it shows for this kind of a category where it says again that it is a single surface that has been added to selection. Whereas over here, it is saying it is an extrusion, and over here it says it's a polysurface, right? Polysurface is nothing but multiple surfaces joined together at its edge. So you can see how this is unique, because even though it has a certain volume inside of it, it is still saying that it is a single surface. So as a result, we'll be treating this as a special case. So geometries like spheres and geometries like ellipses and torus will all be your special cases. So torus, if you want to see, yeah, it's your. So even this, when you select it, it's basically like a donut, right? So even over here, you can see that it is saying it's just a single surface, right? And if you notice, it even has a surface seam, right? Like it has an edge. So this is the edge that I'm talking about. I'm going to just turn off. Yeah, you can see the surface has started forming and ended forming over here in the sphere. It's very similarly represented as over here as an edge in the cuboid, right? All right. So let's try and get a hang of the tools that we used just now. So I want you guys to try out these tools along with me now. So first thing is single points. So you can see in the standard toolbar, you have the single point icon over here. And if you notice, there are multiple ways how you can execute a single command in Rhinoceros, as I was mentioning even during the introduction. You can execute the same command through the menu bar over here. You can either type in the command over here in the command line, and the command line works very in a similar fashion to your Google search, right? So the moment you type in line, anything and everything that is related with line will immediately be shown over here in your command line drop down menu. So you can even select over here as to what you want to execute. So you have line, and you can give it a start point and an end point, and that creates a line. Right. The same thing you can do it even over here in the curve section. You can go to line. You can create single lines. You can create line segments. You can, yeah, there are multiple things that you can do over here. And of course, polylines, rectangles, polygons, or you have freeform curves that you can also draft out. Right? So all of these things are there over here as well. So you can go either to curve drawing, right? Or you can go down to this small little triangle that you see at the end of the icon over here, and that will bring open a small menu right outside of it. You can select either single line or polyline or line from a midpoint, line from line that's normal to a surface, and so on and so forth. for now, I just want you to get a hang of like, let's say for example, single line and polylines. Point is very straightforward. I hope you have already got a hang of that, right? To populate multiple points, you can right click on the icon and that allows you to populate multiple points. Okay. And also whenever I'm executing any command, I want you to keep an eye on, the command line, as I was saying, like if I hit enter now, or let's say for example, I right click on this icon, you're going to see it's asking me for the location of the point object. So I'm going to say this is my location for the point object. Then it is asking me to either set a location of the point object or press enter when I'm done. So let's say for example, I want to locate a few more objects and then hit enter. That marks the end of that command sequence, right? So that makes it very easy for us to keep a track of when we are starting a command and when we are ending a command. Right, guys, does anyone have any doubts? The point section, I believe it's clear to you guys. Okay. Another small thing that I want to add in.
Excuse me.
Yeah.
Yeah, I had one doubt.
Yeah, tell me, Shashwat.
So before drawing the lines and the points, we have to determine the layer and properties as well. Is
No, that will be default. So by default, your layer and all will be set to default. And these things we'll get to it later on. Right now, I just want you to use the default layer at the default settings and just try to get a hang of the tools.
Because I was thinking if it was used as an extension for AutoCAD, then Rhino can also be used for drafting, right? Like CAD.
Yes, Rhino can be used for drafting. Although primarily Rhino would be a tool that you would use for form finding and organic tool modeling.
Okay.
Okay, so yeah, you can use it for drafting, although it's not, how do you say it? It's not a tool that you can rely on for drafting, basically.
Okay. Because user wise, I think this is more friendly, like little more friendly than CAD when it comes to making free flowing curves and
yes, and that is the point of it. That is the whole reason why designers use this tool, is because it's more, let's call it forgiving, right? And yeah, as you say, it's more forgiving and it's more easier, and it's just more convenient to find a form in this tool than on tools like SketchUp or AutoCAD or Revit or something like that, where you would have to give in a lot of other details to draft out a geometry, whereas over here it's more like a freeform thing.
Yeah, cool.
All right, I see Antali has asked a doubt saying, is it a default setting? Okay, Anjali, no, it's not a default setting. It's a default setting. By default, yes, it will come as a wireframe. But of course, as you can see in the perspective, I had changed it to shaded mode, right? Which you can do it with the help of this drop-down menu. We'll get to these things also. All right, and Diksha, see, panning in the ortho viewports is with the help of your right mouse click button. Okay. Or you can go to standard toolbar over here and you can select this pan view icon and you can then pan around. Okay. So that's for the ortho viewports. And for the perspective viewports, if you're going to use the right mouse click button, it's going to orbit like this. If you want to pan over here in the perspective, you can click the right mouse along with shift. That allows you to pan around in the perspective viewport. Does that solve your doubts? All right, cool. Uh, yeah, so right now we have it in shaded mode in the perspective and wireframe in the top view. Okay. Now going forward, yeah, we have learned about the points and we have learned a little bit about the curves. In the curve section, you have lines and polylines. You even have closed curves, like you have a circle from center to radius. So if you want the center to be that and radius to be this, you have a circle like this. You have ellipses. So you can set out ellipses like this. And you have rectangles, and you can even explore these things. Post this class, you can even explore these things. You have rounded rectangles, wherein you can set a rectangle and give it a fillet. So that gives you a rounded rectangle like this. So you can explore these tools later after this class as well. But right now, to get a hang of the different types of geometries, yeah, you can skip over it and you can come down to surface from 3 or 4 corner points. So that allows you to draft out 4 points between which it will create a surface like this. Okay. And yeah, these points need not be planar. I mean, if you are looking for a non-planar something like this, you can go for something like this as well. Okay. And while you're executing these commands, I hope you're getting a hang of how snapping works, right? So one thing, as I was saying, is grid snap, right? So I'm going to give you a demonstration of how grid snapping works. I want you all to pay attention over here and then try it later on by yourself. So first thing is I'm going to keep it like I have the grid snap on right now, and I'm going to execute the same command, that is surface from 3 or 4 corner points. Now you can see how if I start it over here and take it forward, it's snapping to the grid intersections, right? Now in between my command execution, I can even turn it off. And now you can see that it is not snapping to any of the grid intersections. So now I have more flexibility in terms of where I want the corner of the surface. So is that making sense? How grid snap and how grid snap on and off affects the modeling? I want you guys to try it out with it.
Excuse me, sorry, one more doubt.
Tell me.
Yeah, so if we want to set a particular size of the grid and increase the size.
We can do it. We can do it. We'll get to that. The settings and all, we'll get to that later on.
Okay, okay, cool.
Guys, if anyone has any doubts or like is not getting a hang of zooming, panning, orbit, or any of the tools or execution, workflow of the tools, just either raise the questions over here or ping it on the chat. Yeah, any of it will do. But don't just breeze through this class and then later on, it will just create trouble for you late in the later classes. Are we all through with points, curves, and surfaces? Okay, so finally we have solids. So you have to select the 2 corners of the cuboid and then give it a height that will create a cuboid like this. And another type of solid would be sphere or ellipsoid, whatever you want to go for. So we can go for ellipsoid now, since we have already tried for sphere and torus over here. So ellipsoid asks for first radius, second radius, and then the height. Right? Basically like an egg shape. Okay. Now another thing, another small gizmo or tool, whatever you want to call it, is your ortho. I'm going to keep the grid snapping on, and I'm going to try and draft out polyline. So I'm going to start it over here. Okay. Now you can see that it is not snapping to the ortho. It's not snapping to the x-axis or to the y-axis, right? If you wanted to snap to the x or y-axis while you're drafting, you can always hit shift. The moment you hit shift, it will snap to the orthogonal axis. So you can see how it is changing from either x or y. Okay. And can anyone tell as to why it is switching only from x and y and not to z? Like we are in the perspective, right? But it's still not switching to z. Okay, the reason is because the perspective has a construction plane that is set to the base XY plane. So you can see the construction plane like this. There's the base XY plane on which we are constructing right now. Okay, so as a result, it will be switching only between X and Y. By default, Rhinoceros will have a color assigned to each of these axes. So you have X assigned with red and Y assigned with green, and Z will be with blue. And that is typically in the case of a gumball that you will see. However, in the case of front viewport or right viewport, you will see it again as green in the Z-axis. Now you can see the differences of drafting in either the top viewport or the perspective viewport, and the difference between these two and the front viewport and the right viewport. So let's try and do that now. So I'm going to start drawing a polyline over here. Okay, so I don't have the ortho on, so I'm going to press shift to keep the ortho on. Then I'm going to again press shift to have it something like this. And after these 3 points, I'm going to now switch to the front viewport. Do you notice how as soon as I switch to the other viewport comes on like this with the highlight on the respective name tag? So keep a note of that. That means that your front viewport is now activated and you're now constructing on the front viewport. So now whatever you're drafting is all coming on another base plane. So that base plane is XZ as it is marked over here. You can see it. Correct? Now I'm going to switch to right viewport again. And if you notice, I haven't, entered out of the command sequence. I'm still using the same command, that is polyline. All right, you can go ahead and draw out anything. And now I'm pressing enter to end the command sequence. Now I want you guys to just take a look at this entire polyline section. So the first section, we drew it on the top viewport, wherein you can see these 3 other points. Correct? So you have it all on the base XY plane. And then we started drawing it on the front viewport, which had the base construction plane of XZ. Z. So you can see that over here in perspective that all of these sections of polylines are all in one plane, that you are seeing it over here. Correct? Finally, we did it on the right viewport, and you can see those parts of it over here. Is this making sense? Are you able to understand how these viewports work in tandem? Like they work together, but still they have different construction planes. Okay. And if you notice, another thing that's really interesting is that the plane starts off right where we have ended the previous segment of the polyline. Like say for example, we started over here and we ended over here in the top viewport. The next point that we selected was in the front viewport, that was this point. And you can see that it is in the same plane as of the previous point, that is this one. Is that making sense? Are you able to understand what I'm trying to say? The same way, then we went on ahead to draft out this segment, this one, then here, and finally we ended it over here. And then we went on to the right viewport, which you can see is again in the same base plane as of this point over here. Correct? Now all that is happening because we had the planar section on. The planar gizmo over here is on, because of which it is sticking to this plane. Otherwise, it would have gone to the base plane, that is the zero plane of YZ. So let's try and do that also once. I'm going to turn off the planar now. I'm going to move this aside, move all of these aside as well. We'll get to using the gumball. So what I use to move these things is called a gumball. We'll get to it later. So I'm going to again start with the top viewport. Okay. And now I'm going to go to the front viewport. Okay. And finally, I'm going to go ahead to the right viewport also. I'm going to just hide out all of these geometries and bring it out what we constructed now into the full bleed. And you can see how the initial section is aligning well with the base XY plane. Correct? So that is that. And this was the last point that we constructed in the base XY plane. Correct? And then we switched on to the front viewport. Okay, Disha, I think I missed your chat over here. You were saying me, you're asking me to repeat some part. Which part?
I just wanted to know why the part about the z-axis, you said the z-axis is missing.
Yeah, so that is because of the construction plane, which we are discussing now.
Okay.
Right?
Yeah.
So perspective has a construction plane set to world XY plane. So
okay.
As a result, it won't snap to the Z-axis.
Okay.
Got it?
Yeah.
So yeah, now we're just learning a little bit about the planar section over here. So yeah, this polyline we started off with on the top viewport. So we have this entire segment of this polyline, which we ended over here in the top viewport. Correct? And then we went on to the front viewport. Now you can see how in the front view, while we switched to the front viewport, it went to the base XZ plane, and it went to the base plane. Like you can see, it is aligning with this red axis over here.
Yeah, I got it.
Correct?
Yeah.
So you can see how it is aligning with this axis. And the same way, we ended this section of the polyline over here, and then we went on to the other plane, and that also you can see it over here.
Yeah.
Got it?
Yeah.
So that's how you can turn on or off this planar section, and you can make use of it. So what I'm trying to say is basically your top viewport has a base plane of XY, meaning to say whatever you're constructing in the top plane will all be drafted on the XY plane. The front viewport has XZ as the base plane. So everything that you're constructing is on the XZ plane. And the right viewport has ZY or YZ, however you want to call it. Okay, perspective allows you to see all of these things together. Okay.
Yeah, got it.
All right. All right. I hope you have gotten a hang of all the different types of geometries as well. Just the types, like we have points, we have curves, both closed and open. Then we have surfaces, and then we have polysurfaces or solids. And of course, finally, we have the unique cases or special cases, we can call it, which are basically going to be represented as a single surface, but it is actually something that is having an entire volume within it. Okay, I want you all to just try these things out, whatever we did. I want you all to get a hang of the different viewports. I want you to execute a polyline or a surface, anything in multiple viewports. Like I'm going to start a surface in the top viewport now. The second point still in the top viewport. The third point I'm doing it in the front viewport, and the fourth point I'm doing it in the right viewport. So if I select that one, you can see how it is different. Correct? Yeah, but I could explain the planar tool again. Is there a specific part of it that you didn't understand? And Ahmed, it will be better if you can just be vocal. I mean, if you can turn on the mic or something.
Yeah, so basically, I didn't understand the function of the planar tool. So you told me that it aligns with the kind of the plane that is there. Like for example, if you're working in the top view, it
Correct.
aligns with the XY axis.
Correct, correct. Okay, so I'll just explain it to you with the help of this exact example that we were trying to do now.
Yeah.
Okay, so right now you can see the planar is turned off, right? The planar gizmo is turned off.
Right.
Okay, so now what I'm going to do is I'm going to start with a polyline only, let's say. So I am drawing it in the top viewport first.
All right.
Okay, so you can see in the perspective viewport that everything is being constructed in the base XY plane.
Right.
Correct. Now what I'm going to do is I'm going to switch to the front viewport.
Mm-hmm.
Okay, now can you see how the cursor is aligning in the right viewport?
Mm-hmm.
It is along the green axis. Can you see that?
Yes.
So that is what I mean when I say that it is going to align with the base XZ axis, and it is doing that because I have the planar turned off. Now keep a notice of the same thing, and I'm going to turn on the planar option over here. And now can you see how it is aligning on the right axis?
Right. Yeah.
Now do you get an understanding of how it is working?
Yes, got it.
Okay.
Thank you.
Guys, anyone else who has any similar doubt like this? I'm going to go ahead to the right viewport also now. So you can see how it is aligning, right? So this is with planar on. Got it? So you can see all of these lines are all aligning in a plane. Okay. This is a very important concept to grasp, and if anyone is not able to understand it, please let me know right now itself. Okay, fine. Going forward with selection in Rhinoceros, it works in the same fashion as in AutoCAD. If you're going to select anything from top right to bottom left, it will select anything and everything that is completely falling inside the box. And if you do the same with top right to bottom left, it's going to select anything and everything that is even partially falling inside the box. Okay, it's just like your blue selection and green selection in AutoCAD. Got it? So if I want to select everything that is inside the box, I can do this. Whereas anything and everything that's even partially falling inside the box, I can do it. And now I want you to just draft out a simple surface, a very simple surface that is going to resemble a part of a, let's say, a meshed hyperbolic paraboloid. So I'm going to start using the surface from 3 or 4 corner points. I'm going to draft out 2 points in the top viewport, the third point in the front viewport, and the final one in the right viewport. So I wanted to get form something like this. Anyone who has any doubt, or let's say for example, you want to share your screen, want to understand what's going wrong, let me know, and we can do a screen share also. Okay, fine. If you have all gotten this, shall we move forward? Guys, I want it to be interactive. Please tell yes or no, or else I'm going to be just, skipping over, or we're going to be going too fast, too slow.
Excuse me.
Yeah, sure, tell me.
Yeah. So after drafting the points, how do you convert it into a surface?
See, the tool that we used was surface from 3 or 4 corner points. That means the moment you specify the points, it will already create a surface for you.
Okay. Okay.
Okay.
Okay.
So that is this one. You can see the icon over here, right?
Yeah.
Yeah. So you can use that icon.
If I'm using the polyline tool for making a surface, can I convert that into a surface, or do I have to use the surface tool only?
Sorry, can you please come again?
Yeah, if I'm using the polyline tool and I made a surface, a particular one, does that mean that I can't convert that to a surface, or can I convert that to a surface?
See, that is case subjective. Okay, let's say for example, I have a polyline which is planar. Okay, so I'm going to create a polyline which is something like this, or let's say something a little more complicated. So let's say this is your polyline. Hello?
Yeah.
Yeah, okay. So if that's your polyline and it is planar, what you can do is you can use your surfacification tools and you can go for surface from planar curves. Select the curve and then hit enter. That is going to create a surface between this set of curve that you have created. Okay. At the same time, if it is non-planar, I'm going to delete this. Right, let's say you have something funny like this, right? Now this is not gonna be easy for you to create a surface between, especially not with surface from planar curves, because as the name suggests, it is going to create a surface only with planar curves. But you can try and patch it together like this. Does that answer your question? Meaning to say, if you have any kind of a curve, you can basically create a surface, but the question of whether or not that surface is making sense geometrically is something that is left for us to understand. Okay, so that is where our understanding comes into picture. Like, we have to visualize as to what is the kind of geometry that we want to model, and accordingly create the polylines or the curves, and then use the surface tools to create the surface. Okay. All right. Now let's understand some basic curve drawing and different types of curves that are there. So first thing is, yeah, of course, we have seen all the straight lines and polylines, and we have seen even some of the closed curves like circles, ellipses, and you have like rectangles and rounded rectangles and that sort of a thing. You can, of course, explore this entire section, right? Right from parabola and, tangent, conic sections, and all the way till stars and polygons. The more interesting and the more useful set of tools are right over here, however, in the curve drawing section. So that is the control point curve. Then you have something called as interpolate curve, and then you have handle curve. So these are the three main tools that you will be using to create any kind of an organic curve. And to be very honest, it's going to be your starting point for any organic shape or surface or model. So yeah, to start with, we're going to be using the control point curve first. So I'm going to just click on that icon over there. And yeah, if you see, I find it easier to use this standard toolbar wherein I have docked in this tab of curve drawing. If you want, you can of course, get that curve drawing section from this gear icon, go down to show toolbar, scroll down a little bit, and should find somewhere, yeah, curve drawing. You're gonna find it something like this, and the moment you do that, you're gonna find this kind of a floating tab. You can take it and dock it over here. Since I already have it, I'm gonna just delete this icon. Okay. Now, if this is comfortable for you to use, please go ahead. If not, you can always use the default section also. Like even in the standard toolbar, you have the control point curve over here. It's the exact same thing. Feel free to even use the curve section over here. Go down to reform and then control point. It's again the same thing. All of these things will give you the exact same thing to execute. Got it? Now, I hope you have gotten a hang of how this tool can be used also right now. So the moment you click on it, it asks for you to select the start of the curve. I'm going to say that it's the start of the curve. Then it asks you to keep selecting the next points. And as you do that, you can see how it is changing the profile of the curve. Okay, when you're done, you can just press enter. If you want to repeat the command, you can press spacebar or you can press enter. That's one way to repeat a command. The other way is you can right click with your mouse button anywhere in the viewport, and you can again go ahead and create the curves. And the third way is to right click anywhere in the empty space over here in the command section, and you will find all the different recently executed commands over here, and you can select any one of them. So there are three different ways how you can execute the recently executed commands. Okay. Now, more specifically, I want to just show you the differences between these different types of curves. So first is the control point curve. So what control point does is it basically creates a profile of curve based on the points that we are selecting. These points that we are selecting are called the control points. And what this means is that if you happen to select any one of these points and you happen to move, it will accordingly change the profile of the curve. Can you see that? And all this while I'm using the gumball, right? You can see I'm using the gumball for these things. So gumball is basically a very nice transformation tool that you can use. Makes things a lot easier than using the move command and all of those things. We can use it more precisely, or we can just eyeball it, like I'm right now eyeballing it. I'm just saying, okay, I need to go this much farther ahead or back inside. So you can either eyeball it, or you can give it a precise dimension also. Like I can click on the icon, like say for example, I'm selecting this single point, and I'm going to click on this arrow. I'm going to say 7 units towards the positive x, and it's going to take me 7 units towards the positive. Right? So that is a control point curve. Now let's go ahead to interpolate curve. That's the next icon that you're seeing over here, interpolate curve. Or in the standard toolbar also, you can go down over here and you can find the interpolate curve. Okay, so the difference, I want you to make a note of it. I'm going to just draft out a few points for that. The first one was control point curve, and the second one is interpolate curve. I'm going to use the same bunch of points to go through, and you can see how these two are different. The first one has the control points at the location that we drafted, whereas the second one has the curve passing through the points that we drafted. But for the second curve, the set of control points is different. Are you able to understand what I'm trying to say? The first curve has the same control points that we are drafting, whereas the second one has the curve that the curve will be passing through the points that we are drafting. Okay, and finally we have something called as handle curve as well. It basically acts like a, your pen tool in Photoshop. Let me just draft it outside of this so that it's easier for us to understand. Yeah, this is handle curve. So I'm going to start off over here. So that's our starting point of the curve. And the next point that I'm specifying over here is actually the control point. And the next point after that I'm going to be specifying now is going to be another point through which the curve will pass. And after that, it's going to be the control point again. Again, it's going to be a point through which the curve will pass, and then it will be again the control points. So can you see how it helps us to control not only the location of the point through which the curve is passing, but also the location of the control point of the curve. I want you all to just draft out 3 different types of curves like this, and I want you to understand the differences between these 3 curves also. Yeah, Anjali, after you hit enter, the curve will be let alone. If you want to see the control points for it again, you're going to just have to select the curve. The moment you select it, you're going to be able to see the control points again. Of course, if you select multiple curves, you're not going to be able to see the control points for all of these curves until and unless you select the points on icon. The points on icon is going to be here. I want you all to take a note of this. You can turn on the control points for any of the objects that you have selected with the help of points on icon over here. Okay, and this has a shortcut also. So say for example, I'm selecting these curves and I can press F10. Although if I do it now, it's gonna, I think, close my Zoom call or something like that. It has some function like that also. So I'm not gonna press F10, but yeah, you can try it. And it's gonna be a function F10 in some of your cases based on the kind of laptop that you have. Okay, but the safest option is to select the object and turn on or off the control points.
Excuse me, sorry. What is
Yeah.
F10 for again?
F10 is a shortcut. You can use it to either turn on or off the control points. Actually, turn it on. To turn it off, it's going to be F11.
Thank you.
And it depends. Like HP and I think Acer has it as function F10 and function F11. I think Dell and Predator and Alienware and all of these laptops have it as just plain F10. So yeah, you guys figure it out.
I think my gumball tool also helps in making a surface because the curve that I just created became a surface.
Yes, Gumball does help you to create a extrusion out of a curve. I'll just show you how. So if you
Yeah,
have this curve like this, and if you're gonna select, like if you're gonna click on the point on the arrow, and you're gonna pull it up, it's gonna create a extrusion like this. So avoid that. Instead, when you're selecting a curve, you can just select one of the points or like even two of the points, and you can just move it up or down like this, and that is going to help you to sort of change the profile of the curve. We'll be looking into Gumball extensively in one of the classes. It's a very effective and very useful tool. We'll be looking at that. Right now, we're going to be using it to just move things around like this, or you can like you can even rotate it. Like if you use the arc that's there over there, you can use it to rotate. All right, guys, any doubts?
I have a doubt.
Yeah, tell me.
Even after I extrude the curve, I'm
Mhm.
able to rotate the curve as well, the profile
Yeah,
of
yeah,
the
yeah.
curve.
Yeah,
Can
you
you
can,
just
you
tell
can.
me infinite number of times?
Yeah, you can. See, the curve and the extrusion are not related.
Okay.
They are related only up until you have, you're making the extrusion, right? Like say, for example, okay, I'm just gonna delete all of these things so that it's more clearer as to what I'm trying to say. Okay, now let's say, for example, I have this curve, which I have extruded, something like that. Now, this extrusion is a different geometry altogether. It is nowhere related with the curve that we have drawn initially.
Okay.
Extrusion is a different geometry. So you can, of course, take this curve, again rotate it in any which way you want, and you can again extrude it in any which way you want.
Okay.
Got it?
Yeah.
Okay. This is again a different. All right, let's do a simple exercise. I believe you all know Calatrava's twisting torso. Right? Let's try and model out something like this. Okay. What we're going to try and do is we're going to we're going to start the model with a regular cuboid, which is basically like a long block, like a tall block. and then we're going to just twist it. Okay. Just deleting everything now. So just keep a note of where I'm starting the block. Okay, I'm starting it somewhere like this. I'm keeping the center, the origin in the center of the block, and then I'm going to give it a height. Let's say 200 meters. Or right now it's an mm. Okay, I'm not going to bother. Let's consider it as meters. So that's like our plane, cuboid. We have already understood as to how we can create a cuboid. We have just made assumptions about the height of the building and the overall dimensions, like the length and breadth of it. Right. Now I want you guys to go to transform tools. Okay. And towards the end, we have some really exciting tools. You have something called as twist, you have something called as bend, you have taper, you have flow along curve, all of these things. Right now, we're going to be focusing on twist and bend and taper. Okay. So first, what we're going to do is we're going to do a twist. Right. Now, as soon as we select that icon, I want all of you guys to look at my screen. Okay. Before trying it out, I'm going to give you time to try it out. So it's asking me to select the object to twist. So I'm going to select the object. Okay. And once I'm done with that, it's asking me to hit enter. So I'm going to hit enter. Now it is asking me to select the twist axis. So I'm going to go to wireframe and I'm going to select the origin. And then I'm going to go to one of the front or right viewports and I'm going to select the Z axis as the axis. Now, once I'm done with that, it's asking me to select the first reference point, like an angle reference point. So I'm going to give this one and then another reference point as the second reference point. Something like this. So in the end, what you get is something like that. You got it? So basically, this point, as it is going up, it's moving over this point of the ground curve. Right? That's happening because we selected the twist. Like I'm going to go ahead and do that again. That's the origin. We have that. So I'm going to do twist. I'm going to select the origin and then I'm going to go out to the front viewport. I'm going to select the axis. And then in the top viewport, I'm going to select this corner and move it out to 90 degrees. Something like that. So what you're going to see is something like this, which you can see it in shaded mode like this. Yeah, so Anjali, you're asking, is there a reason why we kept the origin at the center? Yeah, the reason is because I wanted to be twisting around the central axis. Let's try and do another twist of a similar kind. So I'm going to make a copy of this. I'm going to copy and do a Control Z. So this was the one that we had made earlier now. And now what I'm going to do is, instead of the center, I'm going to select one of the corners as the axis of twist. Okay. So now again, I'm going to select the twist command, the twist tool. And I'm going to say, okay, the start of the axis is this one, end of it is here. And this is the first reference point, and this is the second reference point. Can you see the difference between the two geometries now? Yeah. So you can see that the axis is absolutely straight. Everything else around it is what is moving. Correct? And that makes geometrical sense, right? So you can see that, yeah, this edge of the block is at the same place, whereas everything else has moved around it. Whereas in this case, the straight axis is right over here at the center of the block, which makes more sense for twist. Okay, so that is twist. Now you can even make it bend. Like say for example, if you want to make this block bend, I'm gonna say bend, and it's gonna ask me to select the start of the spine. So let's say that's the start of the spine, and let's say that's the end of the spine. Okay, let's say that's the start of the spine, there's the end of the spine, and you can do it this way. So you can even make the geometries bend around like this. Okay. Although it's not something that we desire now, but there is another tool that is taper, which may be more desirable for the kind of form that we are trying to find. So tapering allows you to taper it from any axis and from any kind of small and big angle. So for that, again, I'm gonna go to wireframe. I'm gonna select the origin again, and I'm gonna select the axis in the front viewport, and then I'm gonna go down to the start distance. Let's say that is that, and the end distance, I'm gonna keep it somewhere here, and you can see how the block has tapered down. Right? Can you see that? And what I can do is I can again take this and again twist it. You get it? So first I tapered it down, and then I can twist